Hello everyone and welcome. Today we're going to get into vector algebra. Now, don't let that name scare you. Just think of vectors and scalars as the secret rules, the game mechanics of physics and math. Once you get these down, trust me, everything else starts to make a lot more sense. So let's dive right in. To really get this, let's start with a problem that I'm sure all of us have faced, especially if you're a gamer. It's the challenge of giving clear instructions when the pressure is on.
Okay, so picture this. You're in the final circle, your heart is pounding, you see the last enemy. What do you shout to your teammate? What's that one perfect instruction that's going to get you the win?
Look at this. This is literally the difference between winning and losing. If you just shout, "Go 50 meters," where is your friend supposed to go? Left, right, straight into danger? It's a total guess. But if you add "towards the tower," now that's a game-winning command. You've given both the distance and the direction. And that small difference, believe it or not, is the key to this whole topic.
All right, let's take a closer look at that first command, the vague one. This type of information, the one that's just a number, it has a proper name. We call it a scalar. The easiest way to think about it is like the basic stats you see for your character in a game.
So here's the official textbook definition. A scalar quantity has only magnitude. Now, magnitude is just a fancy word for the amount or the size of something. So a scalar basically just answers the question, how much or how many? It's just a number with its unit, like 50 meters, 10 kilograms, or 5 seconds. That's it. No direction.
And here are some perfect examples. The time remaining in the match, your speed, the distance you've covered. All of these are important numbers, right? But notice none of them tell you which way to go. They're just plain numbers. They are all scalars.
So if scalars are the basic, level 1 information, then what's the pro move? What's the upgrade? Well, that's where vectors come in. Vectors are your power-up. They are the tool you use for a winning strategy because they combine both pieces of information you need.
And here's the definition for it. A vector quantity has magnitude as well as direction. It's our winning command from the game, remember? 50 meters, that's the magnitude, towards the tower, and that's the direction. See? It has both.
Honestly, if you remember just one thing from this entire discussion, let it be this simple formula right here. Magnitude plus direction equals a vector. This is the golden rule. This is what turns a simple, basic number into a precise and powerful instruction. Let's look at some examples of these pro moves. Displacement isn't just about how far you moved, it's about which direction you moved in. Velocity isn't just speed, it's your speed towards a particular point. And force isn't just how hard you push, it's about which way you're pushing. Each one of these has a number and a direction. They are all vectors. Okay, so we've got this new pro tool called a vector. Let's break it down and look at its parts, just like you would inspect a new weapon you've just picked up in a game to see how it works.
So, every single move has to start from somewhere, right? In the language of vectors, we call this starting point the initial point. In our game, this is simply the spot where your character begins their action.
And if there's a starting point, there has to be an ending point. Makes sense. This is called the terminal point. It's simply the destination, the place where your player's move ends.
And what about the length of that move? Well, the straight line distance between the initial point and the terminal point is the vector's magnitude. It's just the length of your move. And just remember, distance can never be negative, so the magnitude is always a positive value.
Now, think about this for a second. For any of these moves or positions to make sense, everyone playing needs to be on the same page, looking at the same map. We need a fixed starting point that never changes for anyone.
In vector algebra, we call this universal reference point the origin, and we usually mark it with the letter O. Just think of it like the absolute center of your game map, the coordinate 0, 0. It's the home base from where everything else is measured.
Now, here's a really useful idea. What if we draw a special vector that always starts from this home base, from the origin? Well, that's called a position vector. It's a vector that starts at O and ends at any other point, let's say point P. Its whole job is to tell you the exact address of point P on the map. It's like a permanent GPS pin for that spot.
So this table sums it all up perfectly. On one side, you've got scalars, your level 1 stats, like your health points or the game timer. They're just a number. They only have magnitude. On the other side, you have vectors, your level 2 pro moves. They have both magnitude and direction, like a guided missile or when your teammate pings a location on the map.
All right, fantastic job. We've covered all the basics. So let's just do a quick mission debrief to make sure these ideas are totally locked in.
Okay, just 4 key things to remember. 1. Scalars are just numbers. They only have magnitude. 2. Vectors are the pro move. They have both magnitude and direction. 3. Every vector has a starting point, the initial point, and an ending point, the terminal point. And 4. A position vector is like a GPS, always starting from that fixed origin.
And why is this all so important? Because what you've just learned goes way beyond your exams. This difference between a simple number and a number with direction, well, it's fundamental. It's literally the code that powers the physics in your favorite games and the navigation systems that help fly rockets to space.
So, I'll leave you with this final thought. We used a gaming analogy to understand vectors, but let's just flip that around. Now that you know what vectors are, how do you think game developers use these exact concepts to control every single movement, every bullet's path, and every interaction you see on screen? It's all built on this. Pretty cool to think about, right? Thanks so much for watching.